Hello and welcome to this course on MATLAB programming for numerical computations. We are in week 12, which is the final week of this course. In this week, we are revisiting some of the examples that we took in the first 11 weeks, and in this particular video, I am going to talk about a couple of examples where you have already combined two different numerical techniques in order to solve a more complex problems. Let's go to some of the examples without a further ado. Okay, the first one is the shooting method. Okay, you remember in week 10 what I said is shooting method is not a very practical method for solving ODE boundary value problems, but it's a very important learning tool. And this is the reason why it's an important learning tool, because it is a method that combines ODE initial value problems with solution of nonlinear equations. What do we mean by that? Is first, what we did is we wrote y equal to dt by dz. Using that, we converted okay. Then we say let's guess I think we took as minus 50 in this particular example, and see what we get as the temperature in the rod. Okay. So, when we did that, the temperature in the rod came like this, and it went significantly above 25, which is the temperature at the other end. Then we guessed y0 minus 450, and when we guessed y0 equal to minus 450, we got a value something like this. Okay. So, this was our target value. Okay. So, with one guess we got a value above the target value, with another guess we got the value below the target value. So, we used bisection rule. Alternatively, we could have even used Newton-Raphson. Okay. So, we solved ODE initial value problem . Okay, obtained residual T target was 25, okay, and improved initial guesses using bisection, or we can use Newton-Raphson also. Okay. So, this was the third point. Okay. So, we reformulated a second order ODE into a set of first order ODEs, solved that ODEs, saw how far off we were from the target boundary value, and we kept iterating using any nonlinear equation solver. In that particular example, 2 weeks back we chose bisection method, but we could choose any nonlinear equation solver in order to solve the resulting ODE IVP. So, shooting method was a combination of ODE initial value problem with a nonlinear equation solver. To summarize what I have said, this is the overall summary. Step 1 was to convert to set of ODEs. Step 2, guess an initial condition for y0. Step 3 was solve the ODE IVP, not BVP. Solve the ODE IVP with the guessed initial condition and check the final value at t at z equal to 1, and improve the guesses iteratively using either the bisection method or Newton-Raphson or any other nonlinear equation solving method. That is how we showed in week number 10 how shooting method works. Then what did we cover in week number 11? In week number 11 we covered partial differential equations, method of lines, Maybe you realized it, maybe you did not, but let us reevaluate what we did in method of lines. What we did in method of lines is we replaced this with numerical differentiation. Okay, we differentiated this as Ti plus 1 minus 2 Ti divided by h squared. Okay, and once we did this differentiation, we had converted this one single PDE into a set of ordinary differential equations. That set of ordinary differential equations was ODE IVP, initial value problem in time. Okay, so we started at t equal to 0 and use ODE 45 or ODE 15s to move forward in time. So method of lines was nothing but a combination of numerical differentiation with ODE initial value problems. So these are the two examples that we have already covered in the previous weeks. So to recap what we did in the method of lines we use central or upwind difference formula for each of the spatial derivatives. By doing that, we were able to convert the ODE and convert the PDE into ODE, a set of ODEs in time, and the resulting ODEs in time, the ODE IVP, we were able to solve them using our chosen numerical technique in order to solve the overall original partial differential equation. Okay. So with that, I come to the end of this lecture. So this was the second lecture of the final week of the course. In the next couple of lectures, I am going to take a couple of examples to show you how the numerical techniques can be fairly powerful. Okay. So thanks for watching and bye.